Welcome back. So we're going to finish up our study of arc length. And this problem's not in your notes, I don't believe. We're going to find the measure of the arc ABC. All right? So notice we're given the measure of arc AC, but we're not given the measure of arc ABC. The video is going to pause in a moment, and I'm going to ask you, what's the measure of arc ABC? Right? We'll write in that arc. So you'll have in the question that arc AC is 45 degrees. What's the measure of arc ABC? And look carefully at this picture, and I think you'll figure out what to do. All right, so thank you for answering the question. All right, so hopefully you saw that together arc AC plus arc ABC equals the entire circle. We know that arc AC is 45 degrees. If we subtract 45 from both sides, it means that arc ABC is 315 degrees. So now we have the measure of arc ABC, and we can find the length of arc ABC. So I'm not going to put the arc measure over that one because we're looking for length here. All right, so we're going to take the central angle, which is 315 degrees, over the whole circle, which is 360 degrees. That gives us the fraction of the circle, and then times 2 pi r. All right, and the radius is 14 centimeters. So 2 pi times 14. All right, and I'm going to write it again so I don't mess it up. So arc ABC is, and everyone can see it later on, 315 divided by 360 times 2 times pi times 14 over 1. All right, and maybe you want to start with the 2 and the 360. All right, those are both even numbers. 2 divided by 2 is 1. 360 divided by 2 is 180. Right? You might think, hey, 315, that ends in a 5, and 180, that ends in a 0. That's got it. They're both divisible by 5. All right, so 315 divided by 5, 31 divided by 5 is 6. I'd have 1 left over, so 15 divided by 5 would be 3. So 63 is what 315 divided by 5 is. 180 divided by 5, all right, so 18 divided by 5, again, is 3. We would have 3 leftovers, and so 30 divided by 5 is 6. Well, 63 and 36, they're both divisible by 9, right? 9 times 7 is 63, and 9 times 4 is 36. I think we're done with the 7, right? Because you can't reduce across the numerator when you're multiplying. You can only reduce a numerator to denominator. We could reduce, though, 14 and 4. Those are both even numbers and both divisible by 2. 4 divided by 2 is 2. 14 divided by 2 is 7. Now, one thing you want to be really careful with is you don't want to crowd your work and make it too hard to find your reducing. If you give yourself plenty of space and just keep reducing vertically, you'll see what you have left at the end here. So 7, 1, of course the pi, and a 7. And the denominator, we only have a 2 and a 1. So that means that the length of arc ABC is 7 times 1 times 7 times pi. That would be 49 pi. And then 3 times 1 is 3. So that our length of our arc here is 49 pi thirds centimeters. And if we found the length of arc AC and added them together, again, we would have the entire circumference of the circle, right? Because together, arc AC and arc ABC make up the whole circle. Let's solve another problem. This one is in your notes. Oops. And we've got various things moving around here. No problem. We'll just write in centimeters. There we go. All right, so we'll make it not as easy. We'll make it a little bit tricky problem here. All right, we're given, there we go. We're given the measure of this arc here, FG, is 134 degrees. All right, and so follow along, and you can add this to your notes as well. We know that the measure of the arc in degrees is the same as the central angle in degrees. So this is 134 degrees as well. 8.1 is the radius. All right, so now let's find the length of arc FG. All right, so we take the central angle, or the arc, they're the same, in degrees, so that's 134 degrees over the entire circle, 360, and then times 2 times pi, and the radius is 8.1. And I'm just going to write that again so I don't have to mess up my first one. Oh, and let's put that over 1 so that we reduce properly. All right, so you might see right off the bat, at least the 2 and the 360 could be reduced. All right, so 2 divided by 2 is 1. 360 divided by 2 is 180. Well, let's see, 134 and 180. All right, well, they're both divisible by 2, right? So 134 divided by 2, that would be 67, and that's a prime number, so we're done there. 180 divided by 2 would be 90. So we have 67 times 1 times pi times 8.1, and then we have 90 and 1 in the denominator. So not a whole lot of reducing here. Now let's use a calculator. If when we multiply, if the decimal's gone, we're good. If not, we're going to multiply by a factor of 10 to get rid of that decimal. All right, so we have 67 times and 8.1. All right, so that gives us 542.7. We still have a decimal there. So 542.7 pi, that's a decimal, over 90. And when we write fractions, we don't leave decimals in fractions. Let me write that a little bit neater. 0.7 pi over 90 centimeters. So we're just going to, and actually I'm not going to even write the centimeters in yet because we're still simplifying. We're going to multiply by a power of 10. And it's going to include as many zeros as we have decimal points. We have one value after the decimal, so we're going to multiply the numerator by 10. Now you just can't go multiplying fractions by 10, right? Anytime you want, you can change the value. But if you also multiply the denominator by 10, you're not changing the value at all. Because you see, we're simply multiplying by 10 over 10. And anything divided by itself is just 1. And you're allowed to multiply anything by 1. That doesn't change the value. So now, let's simplify this without that decimal. So 542.7 pi times 10 is going to give us 5,427 pi. And 90 times 10 would be 900. Now sometimes you can reduce after this. And actually this is one where we could reduce because we've got 5 plus 4, which is 9, plus 2 is 11, plus 7 is 18. 18 is divisible by 3, so is 5,427. 900 is divisible by 3. So sometimes you can't see that you still have a factor when you've got a decimal. Now that we've multiplied by, oh wait, I'm sorry. Yes, I'm sorry, that's right. For a second there I thought I left a number out. So now that we've multiplied by 10, we can see we could reduce one more time. So now I will just write right over this. Let's divide both of those by 3, and that should do it. So 5 divided by 3 is 1. We have 2 leftovers. 24 divided by 3 is 8. I have no leftovers. 2 divided by 3 is 0. And I've got 2 leftovers. So 27 divided by 3 is 9. 900 divided by 3 is 300. Now 1809 is still divisible by 3. So guess what? We got to divide one more time because 300 is also divisible by 3. All right, so 18 divided by, maybe I should move this down a little bit just so it doesn't get too crowded. So this is our tricky problem. Let's see if this is the last time that we have to reduce. All right, so 18 divided by 3, that would go 6 times. 0 divided by 3 is 0. And then 9 divided by 3 is 3. So 603. That's not very neat. And 300 divided by 3 is 100. Well, now we are done, because now they don't have anything in common. So the measure of arc, and I'll write it over here, the measure of arc FG is going to be 603 pi over 100, and that is in centimeters. So this was our tricky problem. All right, make sure you put this one in your notes, and if you need me to pause, no problem, I'll pause for you. Right, but now let's look at the next question, right, now that I've paused if I needed to. And let's find the arc length of arc GFH. This one's not in your notes. I like to practice these ones where you are not given the central angle. You have to find it. All right, so this is the measure of this central angle, 40 degrees. But we need this central angle for arc GFH, and this tape's going to pause for a moment while you tell me what's the measure of that arc or angle, since they're the same. All right, thanks for answering. So together, arc GH plus arc GFH add up to the entire circle. Since arc GH is 40 degrees, if we subtract 40 from both sides, arc GFH is 320 degrees. So that means this, in here, this is 320 degrees, and that's our central angle. To find the length of arc GFH, we're going to take the central angle, which is 320 degrees, divide that by the entire circle, which is 360 degrees, times 2 times pi, and the radius is 6 meters. And all over 1. So we don't have any trouble when we're reducing. All right, I think the easiest thing to cancel off are these zeros. Right? On 32 and 36, they're divisible by 4. 32 divided by 4 is 8. 36 divided by 4 is 9. 9 and 6 are both divisible by 3. 9 divided by 3 is 3. 6 divided by 3 is 2. You can't reduce anything from, you can't reduce from numerator to numerator, right? So you cannot reduce the 8 and the 2 and the 2. Right? And none of them have a factor that's in common with the 3. So we left with an 8, a 2, a 2, of course the pi, and in the denominator a 3 and a 1. So 8 times 2 be 16. 16 times 2 is 32. So 32 pi thirds, and this is meters. And we've done it. And I hope you see that these really aren't too hard. You just need to set it up correctly, identify the central angle, right? And then it's central angle over 360 times 2 pi r. Identify your radius, reduce, and then multiply all the terms that are left in the numerator and all the terms that are left in the denominator. And actually, you're only going to be left with one term and a 1. All right, so this is a fill-in in your notes. The length of a semicircle is half the circumference. Right? So now, if it's half the circumference, right, that makes sense, right? Because 180 divided by 360, right, that would reduce to 1/2. The length of a 90-degree arc is 1/4 the circumference. Well, 90 over 360, right, we could cancel out the zeros. We're left with, and actually we could have canceled them out here too, 18 over 36. And we're left with 9 over 36. that's going to be 1/4. All right, so that makes sense that a semicircle would be half the circumference, and the length of a 90-degree arc would be 1/4 the circumference. So that's just to fill in your notes. And let's do some problems like this in a moment. First, let's look at one thing, congruent circles and arcs, and compare that to arc length before we solve a few more problems. So when using degree measures to compare arcs, two arcs are congruent if they have the same number of degrees, even if the circles aren't congruent. When using linear length to compare arcs, two arcs are congruent if they measure the same number of degrees and they are arcs of the same circle or congruent circles. So for instance, here we have an example, arc RS and arc TU. So here is arc RS and here is arc TU. They both measure 90 degrees. So in degrees, those two arcs are congruent. However, arc RS and arc TU do not have the same linear arc length because they're not from congruent circles. So all circles are similar, right? So the arcs are going to be congruent if they have the same number of degrees. So the central angle, the red arc, arc RS, and the green arc, arc TU, are all congruent because they all measure 90 degrees. However, the length of arc RS and length of TU are not the same because the circles aren't congruent. So if your circles aren't congruent, your arc length isn't the same, although your measured degrees will stay the same. Let's find the length of arc AB. We see that it's a 90-degree angle. I don't have my formula on this one. Just as a reminder, arc length is central angle divided by 360 times 2 pi r. If you had the diameter, you could use pi times diameter. Or you just find the radius. So here the radius is 7 inches. The length of arc AB is going to be 90. So that's a right angle over 360 times 2 times pi times 7 all over 1. And if we remember that if we have a 90-degree angle, it is, actually I'm going to stay in the same color, it is 1/4 of the circumference. So AB, we could just reduce the 90 and the 360 to 1/4 times 2 times pi times 7. Now we still could do a little reducing because we could reduce the 4 and the 2. Numerator to denominator. 2 divided by 2 is 1, 4 divided by 2 is 2. And that's all we can do because now we see the measure of the length of arc RB is going to be 1 times pi times 7, that's just 7 pi, all over 2 inches. Now if we wanted to find the circumference, since that's 1/4 of the circumference would equal 4 times 7 pi over 2. All right, and those would cancel. So that means 14 pi inches would be the circumference. And since the radius is 7, and 2 times 7 is 14, the diameter is 14, that is certainly correct. Right? So if you have an arc, and you know what portion of the circle it is, in this case it's 1/4 of the circle, we could just multiply by 4 and we would find the circumference. Find the length of the arc shown. So notice that the arc is not, it's like a piece missing of the circle, right? So the arc is the rest of the circle. And I don't know if this one might be in your notes. I'm almost 100%, I'm positive this one is at the bottom. All right, so now the arc length, and I'll write the formula right here again for both. Arc length is the central angle divided by 360 times 2 times pi times r. All right, so arc length is going to be 270 divided by 360 times 2 times pi times 13, because here the radius is 13. It's a big circle. The radius is 13 kilometers. Maybe it's like a town square or town, I don't know. like a town circle. All right, so I'm going to write that again. Arc length is like a park. 270 divided by 360 times 2 times pi times 13 over 1. And right away, I think you notice that you could reduce those zeros. And you might realize, hey, 27 and 36 are both divisible by 9. 27 divided by 9 is 3. 36 divided by 9 is 4. 4 and 2 both have a common factor. They're both divisible by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. And now we can just multiply. We've got the 3, the 1, and the 13 in the numerator, and the 2, and of course the pi, and the 2 and the 1 in the denominator. So the arc length is equal to 3 times 1 times 13 would be 39 pi. And then in the denominator we have 2. And this is kilometers. So that's the length of that arc, right? It's 39 pi halves. If we wanted the entire circle, well, that would be 2 times pi times 13, or 26 pi. Find the length of an arc whose diameter of 18 inches and a central angle of 72 degrees. All right, so we've got our central angle. How about the radius? Well, if the diameter is 18, and we could use diameter, or we could just change it to radius and use the formula we've been using. The radius would be 9 inches. So if we work with radius, we'll work with both. And you pick one to put in your notes. If we work with radius, then the central angle, the arc length, I'll just put AL. Arc length, it would be equal to the central angle, which is 72, divided by 360, times 2, times pi, times the radius, which is 9. Right, and 2 and 360 are both divisible by 2, so that would be 1 and 180. 180 and 9, right? They're both divisible by 9. 9 divided by 9 is 1. 18 divided by 9 is 2, and then just another 0. 20 and 72. Well, you might not realize they are both divisible by 4, actually. So 20 divided by 4 is 5. 72 divided by 4, let's see, 7, that would be once. And there'd be 3 leftovers, and 32 divided by 4 is 8. So that's as simple as it gets. We've got an 18 and a pi in the numerator, and a 5 in the denominator. So this would be 18 pi over 5. What is this? Inches. Now we could actually, let's just write this one because it's getting a little crowded. We could use diameter, but then instead of the 2 and the 9, you've got 18. That's fine so long as you realize 18 is a factor of 360. But it might be easier working with the smaller numbers on the reducing. But you could have made the 2 and the 2 pi r. You could have made it pi d, and this would have just been. That would have just been 18 pi, right? No big deal. I'll basically stick to the 2 pi r when we're dealing with arc length, because I think it makes it a little easier for the reducing. And I think this might be the last one. It is. I see a blank screen. So, thanks for watching, and bye for now.